Hi, Assalamualaikum. So in this video, we are going to discuss questions from textbook page 54, self-exercise 2.8. Okay, so question number 1, find the equation of the tangent and normal to the following curves at the given point. Okay, so here the clue is equation of tangent and equation of normal. This is our objective to find the equation of tangent and normal. So you know that if we have curve, okay, and we have tangent is a straight line that touch the curve at one point. Okay, so tangent is a straight line. So equation of tangent is a equation of straight line, okay, which is y equals to mx plus c. So in this situation, we have to find m and c first. Okay, so we know that m is gradient, okay, and gradient is dy dx. Okay, gradient is dy dx. Okay, in this situation is f prime x. Okay, so then you have to find f prime x first. So we have fx is 5x squared minus 7x minus 1. Okay, so at point 1 negative 3, so f prime x is 10x minus 7. Okay, so we have point 1 negative 3. So we substitute 1 is x is 1. So 10 times 1 minus 7 is 3. Okay, so now we already have the gradient and we have to find c. Okay, so substitute into y equals mx plus c. So we substitute y equals to mx plus c. Okay, the point is 1 negative 3. This is coordinate x and y. Okay, y is negative 3. M is gradient. Gradient is dy dx or f prime x. Okay, equals to 3. X is 1 plus c. So then we calculate this one. C equals negative 6. So therefore, equation of tangent y equals to 3x minus 6. Okay, so this is equation of tangent. Equation of tangent. Okay, so next we have to find the equation of normal. Okay, so equation of normal. Normal actually the straight line. Okay, that passes through the same point. Okay, at the same point, 1 negative 3. So and always 90 degree. So meaning that the normal and the tangent is perpendicular. Okay, so therefore you have to find normal is straight line as well. Okay, so equation of normal straight line. Okay, straight line y equals to mx plus c. Okay, find m and c. Okay, so we have relation gradient of tangent times gradient of normal is negative 1. Gradient of tangent just now dy dx, which is 3 times gradient of normal is negative 1. So gradient of normal is negative 1 over 3. Okay, so normal is y equals to mx plus c. Okay, so y equals to mx plus c. So we substitute 0.1 negative 3. Okay, from the question given this point from the question, coordinate 1 negative 3. So we substitute y is negative 3, m is negative 1 over 3, x is 1. Okay, so we find the value of c is negative 3 minus plus 1 over 3, 8 over 3. So therefore, equation of normal is y equals to negative 1 over 3x minus 8 over 3. Okay, this is equation of normal. Okay, next question 1b. You have to find the equation of tangent and normal as well. So the first one, equation of tangent. Okay, tangent is straight line. So y equals to mx plus c. Find M and C. Okay, so M is gradient. Okay, gradient is dy dx or f prime x. So we find f prime x first. So fx is x cubed minus 5x plus 6. Okay, f prime x is 3x squared minus 5. We have x is 2. So 3 times 2 squared minus 5. Which is 12 minus 5, 7. Okay, so this one gradient is 7. Okay, so we substitute into y equals mx plus c. We have point 2, 4. Okay, so put in x and y, we substitute. So y is 4 equals to m is 7, x is 2 plus c. Okay, c is 4 minus 14, which is negative 10. Okay, so therefore equation of tangent y equals to 7x minus 10. Okay, this is equation of tangent. Okay, so to get the equation of normal, so same equation of normal, y equals to mx plus c, find m and c. Okay, so we have relation m tangent times m normal is negative 1. So m tangent is 7, m normal is negative 1 over 7. Okay, substitute into y equals to mx plus c. Okay, just now we have 0.24. Okay, 24. Okay, substitute y is 4, m is negative 1 over 7, x is 2 plus c. Okay, so c is 4 plus 2 over 7, 28 plus 2, 30. C is 30 over 7. Okay, so therefore equation of normal y equals to negative 1 over 7x plus 30 over 7. This is equation of normal. Okay, so the next question, question C. Here we have fx. Okay, so we straight away find fx is square root 2x plus 1. Okay, so f prime x is 2x plus, sorry, fx. Okay, this one. Okay. Power of 1 over 2. So then f prime x, we use composite function power rule. Okay, so 1 over 2, 2x plus 1, power of negative 1 over 2 times 2. So we simplify, we get here 1 over square root 2x plus 1. Okay, now the point is 4, 3. Okay, so 1 over square root 2 times 4 plus 1. 2 times 4, 8. 8 plus 1, 9. Square root 9 is 3, so 1 over 3. Okay, so equation of tangent y equals to mx plus c. We have point 4, 3. Okay, for 3, coordinate x and y. So we substitute 3 equals to m is 1 over 3, x is 4 plus c. Okay, so then we get c 3 minus 4 over 3. Okay, so 9 minus 4. So c equals to 5 over 3. Okay, so here is the equation of tangent. So y equals to 1 over 3x plus 5 over 3. So this is equation of tangent. Okay, So then for normal, for equation of normal, so we have gradient of tangent times gradient of normal is -1. Gradient of tangent just now 1 over 3. So 1 over 3 times gradient of normal is -1. Gradient of normal is -3. Okay, so we substitute into y equals to mx plus c. Okay, so the point here is 4, 3. Okay, 4, 3. So xy. So y is 3. Gradient is -3. X is 4 plus c. So c is 3 plus 12, which is 15. Okay, so c is 15. So therefore equation of normal y equals to -3x plus 15. So this one equation of normal. Okay, for question D, we have fx is x plus 1 over x minus 1. Okay, this one we have to find equation of tangent and normal. We have to find the gradient of tangent first. So this one quite long. You have to use quotient rule. Okay, so u is x plus 1, du dx is 1. V is x minus 1, dv dx is same 1. So f prime x, we have formula of quotient rule, v du dx minus u dv dx over v squared. So minus 1 times 1 minus 1 times x plus 1 over v squared. V squared is x minus 1 squared. Okay, so this one you just simplify, we get x minus 1 minus x minus 1 over x minus 1 squared. Okay, -2 over x minus 1 squared. Okay, here we have 0.32. Okay, so we have 0.32 xy. So therefore, you substitute x equals to 3 minus 1 squared. Okay, here we get the gradient is x 3 minus 1 to 2 squared negative 2 over 4, which is -1 over 2. Okay, so this is the gradient. So we substitute into y equals to mx plus c, the straight line, because tangent is straight line. So here we have formula point y, x and y. So y is 2, m is -1 over 2, x is 3 plus c. Okay, so therefore c is 2 minus 3 over 2. 2 plus 3 over 2. 3 over 2. So C is 7 over 2. So therefore y equals to -1 over 2x plus 7 over 2. This is equation of tangent. Okay, to find equation of normal, you have to find gradient of normal. So gradient of normal, we have formula gradient of tangent times gradient of normal is -1. Tangent just now -1 over 2. So gradient of normal is 2. Okay, so substitute into y equals to mx plus c. Y is just now coordinate 32. Okay, so 32. So 32 xy, y is 2, m is 2, x is 3 plus c. So is c is 2 minus 6 is -4. Okay, so -4. Okay, so the equation of normal is y equals to 2x minus 4. Okay, this is equation of normal. Okay, next question number 2. You have to find the equation of tangent and normal. Okay, for each curve given. Okay, so gradient of tangent, equation of tangent, y equals to mx plus c. You have to find the gradient of tangent. Okay, in this situation, we have y equals to 2x cubed minus 4x plus 3 when x equals to 1. Okay, given only the coordinate 1, coordinate x. So we have to find the coordinate y first. Okay, so we just substitute y is equals to 2 x1 cube minus 4 1 plus 3. So 2 minus 4 negative 2 plus 3. So 1. Okay, so here we have coordinate 1 1. Okay, so 1 1. Then to find equation of tangent, you have to find the gradient of tangent first. Gradient of tangent is dy dx. So dy dx is 6x squared minus 4. Okay, substitute x is 1 squared minus 4. Dy dx is 2. Okay, so then equation of tangent, y equals to mx plus c. Now we have 0.11, so y is 1. M is 2, x is 1 plus c. So c is negative 1. So therefore equation of tangent y equals to 2x minus 1. This is equation of tangent. Okay, so next equation of normal, find gradient of normal first. So gradient of tangent times gradient of normal is negative 1. So gradient of tangent is 2 times gradient of normal is negative 1. Gradient of normal is negative 1 over 2. Substitute into y equals to mx plus c. Coordinate is 1 1. Y is 1. M is negative 1 over 2. X1 plus c. So c is 1 plus 1 over 2. So c is 3 over 2. Okay, so therefore equation of normal y equals to negative 1 over 2x plus 3 over 2. Okay, this is equation of normal. Okay, question 2b, we have y equals to square root x minus 1 over square root x. For x equals to 4, then we find coordinate y first. So square root 4 minus 1 over square root, square root 4. 2 minus 1 over 2. Okay, so y is 3 over 2. Okay, so here the coordinate is 4, 3 over 2. Okay, so to find the equation of tangent, find the gradient of tangent first. Differentiate. Okay, so y is this one. Okay, x power of half minus x power of negative half. Okay, so here 1 over 2 x power of negative 1 over 2 plus 1 over 2 x power of negative 3 over 2. Okay, so this one dy dx, dy dx. Y in terms of x, we differentiate, we get dy dx. Okay, so we simplify first before we substitute. We get here 1 over 2 square root x plus 1 over 2 square root x cube. Okay, so then we substitute x equals to 4 into this equation. So 1 over 2 square root 4 plus 1 over 2 square root 4 cube. Okay, so here I have 2 times 2 plus this one 2 cube. Okay, so 1 over 4 plus 1 over 16. Okay, 1 over 4 plus 1 over 16 is 5 over 16. Okay, this is gradient of tangent. So you substitute into y equals to mx plus c, which the point just now is 3 over 2. Okay, So 4, 3 over 2. So this is x and y. Okay, so y is 3 over 2, m is 5 over 16, x is 4 plus c. So c is 3 over 2 minus 20 over 16. Okay, c is 1 over 4. Okay, so c is 1 over 4. So therefore, equation of tangent y equals to 5 over 16x plus 1 over 4. Okay, so this is equation of tangent. Okay, so the next one, you have to find equation of normal, then find gradient of normal first. So by using m1, m2 equals to -1. Okay, gradient of tangent just now 5 over 16. So therefore, so this one actually gradient of tangent. Okay, so gradient of tangent times gradient of normal. Okay, so gradient of tangent 5 over 16. Gradient of normal is -16 over 5. Okay, so we substitute into y equals to mx plus c. Okay, same point, which is 4, 3 over 2. Okay, so y is 3 over 2. Gradient is -16 over 5. X is 4 plus c. Okay, so c is 143 over 10. 143 over 10. Okay, so therefore y equals to -15 over, -16. -16 over 5x plus 143 over 10. Okay, so this is equation of normal. Okay. Okay, next, question 2c. Okay, c, here y equals to square root x plus 1 when x equals to 3. Find coordinate y first. So square root 3 plus 1, 4 is 2. So coordinate is 3, 2. Okay, so find dy dx. So y equals to x plus 1 power of half. So dy dx is 1 over 2 x plus 1 power of -1 over 2 times 1. Okay, here we have 2 square root x plus 1. Then we substitute x equals to 3. So 1 over 2 square root 3 plus 1. 3 plus 1 is 4, square root 4 is 2. So then we have 1 over 2 times 2 is 1 over 4. So this is dy dx. Dy dx is gradient of tangent. So we substitute into y equals to mx plus c. We have coordinate just now 3, 2. So y is 2, m is 1 over 4. X is 3 plus c. So then c is 2 minus 3 over 4. Okay, 2 minus 3 over 4 is 5 over 4. So then equation of tangent y equals to 1 over 4x plus 5 over 4. This is equation of tangent. Okay, so next, the question asks you to find equation of normal. Find gradient of normal first. Gradient of tangent times gradient of normal is -1 because tangent and normal are perpendicular. So tangent is 1 over 4 times gradient of normal is -1. So gradient of normal is -4. We substitute into y equals to mx plus c with 0.32. Okay, so y is 2, m is -4, x is 3. So c is 2 plus 12. C is 14. Okay, so gradient of normal y equals to -4x plus 14. Okay, this is equation of normal. Okay, question D. Y equals to 5 over x squared plus 1. X is negative 2. Find y first. 5 over negative 2 squared plus 1. So 5 over 5 is 1. So coordinate negative 2, 1. Okay, for this one, we have y equals to 5 over x squared plus 1. So to solve this one, we can move up, become 5 times x squared plus 1 power of negative 1. So we can find dy dx is negative 5 x squared plus 1 power of negative 2 times 2x. Okay, so here we get negative 10x over x squared plus 1 squared. Okay, so the coordinate is negative 2, 1 just now. So substitute x equals to 2. We have negative 10 times negative 2 over negative 2 squared plus 1 squared. So here we have negative 20. Okay, 20 over 2 squared, 4 plus 1, 25. Okay, so here we have 4 over 5. Okay, the gradient is 4 over 5 into here we have coordinate negative 2, 1. Okay, substitute into y equals to mx plus c. So y is 1, m is 4 over 5, x is negative 2. So c is 1 plus 8 over 5. Okay, which is 13 over 5. Okay, 13 over 5. So therefore, equation of tangent negative y equals to 4 over 5x plus 13 over 5. Okay, this is equation of tangent. Okay, so to find equation of normal, find gradient of normal. So same, okay. Gradient of tangent times gradient of normal is negative 1. Tangent 4 over 5. So then normal negative 5 over 4. Okay, substitute into y equals to mx plus c. The coordinate just now negative 2, 1. y1 m negative 5 over 4, x negative 2 plus c. So c is, okay, so c is 1 minus 5 over 2. Okay, which is negative 3 over 2. So therefore, the equation of normal is y equals to negative 5 over 4x minus 3 over 2. This is equation of normal. Okay, question E. Okay, y equals to 2 plus 1 over x. X is negative 1. Y is 2 plus 1 over negative 1. Y is 1. So the coordinate is negative 1, 1. Okay, so from y, so we have y equals to 2 plus x power of negative 1. So differentiate, we get negative x power of negative 2. Okay, so negative 1 over x squared. You substitute x equals to negative 1. So 1 over negative 1 squared is negative 1. So we have point negative 1, 1 into y equals to mx plus c. Y is 1, m is negative 1, x is negative 1. Okay, plus c. So c is 1 minus 1. C is 0. So the equation is y equals to negative x. So this is equation of tangent. Okay, so find equation of normal. So gradient of tangent times gradient of normal, negative 1. So gradient of tangent, just now negative 1 times gradient of normal. So gradient of normal is 1. So into y equals to mx plus c. Okay, point negative 1, 1. So y is 1, m is 1, x is negative 1. Careful, okay? So c is 2. So therefore, equation of normal y equals to 1x. So you just write x plus 2. So this is equation of normal. Okay, done. Okay, for question F, we have y equals to x squared plus 3. Okay, over x plus 1. X equals to 3. Find y first. So 3 squared plus 3 over 3 plus 1. Okay, so 9, 12 over 4, which is 3. Okay, so the coordinate is 3, 3. Okay, so find equation of tangent and normal. Find gradient of tangent first. So this one we have to use quotient rule. Okay, so u is x squared plus 3 du dx is 2x. V is x plus 1. Dv dx equals to 1. Okay, so then you use formula of quotient rule, v du dx. Okay, so x plus 1 times 2x minus u dv dx, x squared plus 3 times 1 over v squared. Okay, so then we substitute. If you can, even if you want to simplify, then substitute also can. Okay, so but now I want to directly substitute. Okay, so here 3 plus 1, 2 times 3. Okay, minus 3 squared plus 3 over 3 plus 1 squared. Okay, here I have 4 times 2 times 3 is 6. Okay, minus 3 squared 12. Okay, over 3 plus 1, 4 squared 16. Okay, so 3 over 12, 24. So 3 over 12. Okay, sorry, 3 over 4. Okay, so this is gradient of tangent. So into coordinate 3, 3. Okay, so y equals to mx plus c. Y is 3, m is 3 over 4, x is 3 plus c. So then c is 3 minus 9 over 4 is 3 over 4. Okay, so c is 3 over 4. So therefore, equation of tangent y equals to 3 over 4x plus 3 over 4. This is equation of tangent. Okay, next, equation of normal. Gradient normal first. Gradient tangent times gradient normal, negative 1. Tangent 3 over 4. So then gradient of normal is negative 4 over 3. Into 3, 3. Okay, so y equals to mx plus c. Y is 3, m is negative 4 over 3, x is 3, so plus c. So then c equals to 7. Okay, so therefore equation of normal, y equals to negative 4 over 3x plus 7. This is equation of normal. Now we move to the next question. Question number 3. Okay, a tangent and a normal is drawn to the curve y equals to x square root 1 minus 2x at x equals to negative 4. Okay, so I think same skill here. We are going to use same skill. So for A, we have y equals to x square root 1 minus 2x. X equals to negative 4. So then find y first. Y is negative 4. Okay, 1 minus 2 times negative 4. So negative 1 plus 8, 9 square root 9. So negative 4 times 3. Okay, negative 12. So coordinate is negative 4, negative 12. Okay, so A, find dy dx. Okay, to find dy dx, no shortcut. We have to use product rule. So, sorry, u is x, du dx is 1. V is 1 minus 2x power of 1 over 2. dv dx is 1 over 2, 1 minus 2x power of negative 1 over 2 times negative 2. Okay, differentiate another time, function in the bracket. Okay, so we simplify, we get negative 1 over, here square root 1 minus 2x. Okay, so then this is product rule. So dy dx. Okay, u dv dx. Okay, so negative x over 1 minus 2x square root plus v du dx. This one square root 1 minus 2x. Okay, so then we substitute x equals to negative 4. Okay, so negative 4 over square root 1 minus 2 times negative 4 plus 1 minus 2 times negative 4 square root. Okay, so here we have 4 over 3 plus 3. Okay, so 4 over 3 plus 3 is 9 plus 13 over 3. Okay, so 13 over 3. 4b, tangent. For b, you have to find the equation of tangent. Okay, so equation of tangent, y equals mx plus c. Okay, just now your dy dx is 4 over 3. Okay, so sorry, 13 over 3. Okay, so 13 over 3 at point negative 4, negative 12. Okay, so we substitute here, y is negative 12, m 13 over 3, x is negative 4 plus c. Okay, so c is 16 over 3. Okay, so substitute into the equation, y equals to 13 over 3 x plus 16 over 3. So this is equation of tangent. Okay. Next, the equation of normal. So same, y equals mx plus c, but we have to find the gradient of normal first. We have gradient of tangent times gradient of normal is negative 1. Just now gradient of tangent 13 over 3 times gradient of normal is negative 1. So gradient of normal is negative 3 over 13. Okay, so we have point negative 4, negative 12. Substitute into y equals to mx plus c. Y is negative 12, m negative 3 over 13, x negative 4 plus c. So c is, very big number. Okay, so c is negative 168 over 13. Okay, so therefore your gradient is, your equation of normal is negative 3 over 13x minus 168 over 13. Okay, question number 4. The tangent to the curve y equals to x minus 2 squared at point 31 passes through K7. Find the value of K. Okay, here we go. We have curve and we have tangent. Tangent meaning that straight line. Okay. Okay, this curve y equals to x minus 2 squared. Okay, the tangent is y equals to mx plus c. Okay, the point, sharing point is 3, 1. Okay, so this tangent passes through, let's say here, K 7. Okay, so the question asks you to find the value of k. For this situation, we have to find the equation of tangent first. Okay, and to find equation of tangent, we have to find the gradient. Gradient is dy dx. Okay, so you start from y equals to x minus 2 power of 2. So dy dx is 2x minus 2 power of 1 times 1. Okay, so then we substitute sharing point, curve and tangent, okay, which is 3, 1. So 2x is 3 minus 2. So dy dx is 2. Okay, so at point 3, 1. Okay, so you substitute into y equals to mx plus c. Y is 1, m is 2, x is 3 plus c. So c is negative 5. Okay, so therefore the gradient, the equation of tangent is y equals to 2x minus 5. Okay, so this equation of tangent passes through point K7. Okay, so then to find the value of K, you substitute this coordinate into equation of tangent. Okay, so y is 7, x is K. So therefore K is 12 over 2, 6. Okay, so K is 6. Next question, question B. The normal to the curve. This is a different question to question A, okay? So B, we have curve y equal to 7x minus 6 over x. Okay, so x equals to 1. So then we have to find coordinate of y, we substitute 7, 1 minus 6 over 1. So 1, okay, same. So coordinate is 1, 1. Okay, so given that the normal to the curve, okay, so then we have to find the tangent first. Okay, gradient of tangent first. Find the gradient of tangent, we differentiate. Okay, y equals to 7x minus 6x power of negative 1. So dy dx is 7x plus 6x power of negative 2. Okay, so y equals to 7x plus 6 over x squared. Okay, x is 1. So plus 6 over 1. So the gradient is 13. Okay, so gradient of dy dx is 13. Okay, but now given the normal, okay, normal, gradient of normal, gradient tangent times gradient normal is negative 1. So 13 times gradient normal negative 1. So gradient normal is negative 1 over 13. Okay, so wait, okay, 13. Okay, so then you have to find the equation of normal first. Okay, like previously you have to find equation of normal. So y equals to mx plus c. Just now we have coordinate 1, 1. Okay, so we substitute y is 1, m negative 1 over 13, x is 1. Okay, plus c. So c is 1 plus 1 over 13. So 14 over 13. Okay, so therefore equation of normal y equals to negative 1 over 13x plus 14 over 13. Okay, so look at the question. Okay, given the clue here, intersect x-axis. Okay, intersect x-axis meaning that y equals to 0. Okay, x-intercept, x-axis is x-intercept. Okay, x-intercept, y0. So then we substitute y0 into normal. Okay, so y equals to 0. So 0 equals to negative 1 over 13x plus 14 over 13. Okay, so here x over 13 equals to 14 over 13. X equals to 14. So therefore, the coordinate A is xy. So 14, 0.